I'm Albert Lionel, and I want to talk about, and this is sort of ironic because you're watching a video about this, but I want to say stop watching and start engaging. When we learn, we only learn if our brain and our thoughts are actually engaged on what's going on and not just watching. Yet, throughout this presentation, I'm going to discuss about how our brain actually lies to us. And our brain thinks that we're engaged in certain situations, when in truth, engagement is really your responsibility in addition to the instructors, but your responsibility to make sure that you're engaged in doing actions along with the learning. So let's go ahead and explore this thought and see how we can better improve by making sure we engage when we participate in courses. So your first lecture in computer science, and this could vary depending on class to class. We're going to say let's study Python. And I want to come back to this later. I'm going to do a really quick lecture on Python so we get the idea. In the first lecture, usually the professor's like, all right, we're going to open up a program. I'm going to go ahead and open up a coding window, and I'm going to show you some code. Let's get started. And so they'll go ahead and open up a coding window. It may have a comment, and you'll say, welcome to Python 101. This pound means there's a comment in front of it. And when they start working on it, they'll go ahead and say, okay, now what I'd like to do for this is I'm going to show you how to print to the console. In Python, the command is print. I can go ahead and type in, and I'm going to say, hello, students. And this is a string between these two quotes. And I have this print and this string, and then I can go ahead and run my code. And here on the console, you see, hello, students. Congratulations, we wrote our first program. And maybe I want to add to that. I'm going to say print, welcome to Python 101. And then I can say this is, of course, a string. We have our quotes between it. Notice that there's a lowercase w there. I actually wanted it to be an uppercase w, so I'm going to go ahead and change that to an upper. If I lose a quote, I lose a string, so I need to add that quote back in there, and I run it. So now you see two lines printed to the screen. Hello, students. Welcome to Python 101. But where's this like jumping between the lines? Well, in Python, by default, it adds a new line character. So I can go ahead and say, hey, I want to change the end by adding a program argument. And now this new line vanishes. And the new line character is actually a hidden character. It's a \n. And I run it, and you see the new line is back there, and my new ending that I added is back there. So I have all this opportunity. We're going to explore Python for the next semester. Well, not really, but most students would sit and watch this. And they'd be really fascinated for the first time, for a lot of students, because it's the first time they're programming. Depending on when you're watching this video, it may not be so fascinating. You may know Python, you may have an idea what's going on. But a lot of people, they're looking like, this is really neat. But then they get home, they open up their IDE, their browser, or whatever they're programming in, and they forgot it all. Or they forgot half of it. Have you experienced that? Have you thought about where you thought you learned something, you really thought you know it, then you get home and it escapes your brain, or you get to an exam and it all goes away from your brain. You thought you knew it, you thought you looked it over, and it goes away. So how do we combat that, and why does that happen to our brains? So when we're watching lectures, and I mean lectures whether it's synchronous online lectures or in the classroom, they can be entertaining, but not always engaging. In fact, studies have shown a really entertaining professor who does what we call the sage on the stage, gives a lecture throughout the whole period, barely leaves time for questions, still gets high ratings as long as they're entertaining. And that's because we have trained ourselves to enjoy entertainment. We have this thrill from it, and we think that we're learning because we're parting all this knowledge, and of course we're going to soak it up. And we don't actually soak it up. Even in asynchronous content, you get videos provided by lecturers, you get online tutorials of YouTube. Asynchronous content is extremely common throughout our careers in computer science. And the moment we get to a video, it gets worse. We notice it. We notice something isn't quite right because our brain isn't quite used to this entertainment, but it is used to watching a video for entertainment. So it's like, okay, I'm going to sit back, I'm going to watch this video. Of course I'm going to absorb it all. Or maybe it's really boring and I just sort of watch it, but then I go ahead and play on my phone or I do other things during the time. So this video becomes entertainment and not engagement. And throughout this entire process, our brains are lying to us. We think we are learning, we think we're taking in this information, but we're not. Why is that? So entertainment actually benefits short-term recall. Many people can sit down and lecture, and right after the lecture, they can recall it. In fact, if you go back to that Python, you may remember the new line characters \n. We sort of reinforced that. But do you remember the parameter needed? Especially if you're new to Python? What was the parameter we needed if we wanted to get rid of the \n? You may start with it and go, oh, maybe it was end equals, since we're talking about the end of the line, and then we do something like that. Maybe you can piece it together. Short-term recall is fine. Short-term recall often goes away when we sleep or after an extended period of time, depending on how our brains tend to work. And it was really great when we need to learn the number of bones in a hand, but we only need it for that one test. But it wasn't really good for understanding and an in-depth knowledge in the future. And the reason why is our brain filters information. It has to. Throughout everything around us, we have this mind here, we have this brain here, and there's tons of input. We have all the sounds, we have all the sights, we have this lecture, we have distractions, we have people talking, we have slides, we have video that may do, and we have our different surroundings of outside. Even as I look at recording this, there's a bird chirping outside, and my brain is registering that. It is understanding that all this stuff is going on, and it needs to pause and say, okay, so all this is going on. How can I select what's important? We've been doing this. This is part of our evolution. We need to select what's important in our brains for survival. And after survival, we say, okay, how do we reinforce? How do I know? And what happens is the brain filters things out, only the important stuff. For most lectures, you're talking about 3, maybe 4 topics that our brain actually wants to keep track of. Anything after that, it's out of there. Our brain can't handle it because it's too much information. It's saying, I only need the important stuff because this is a matter of survival. So then, how do we tell our brains that this is important? How do we tell our brains that we need this information? So don't filter it. Take this and make it priority over maybe a background noise or something like that. So let's think about that. So how do you take control of your learning? Well, there's 3 techniques you can use, and they're going to sound really simple, but the science behind them are actually really strong. And that's ask questions, take notes, and code along. Now, the problem is our asking questions or our taking notes often isn't how we should be doing it, and we'll talk a little bit about that. And code along is actually one of the more powerful tools that we get to use as computer scientists as we learn a lot of our thing. And really, it's more than code along, it's really follow along and do the same thing. But for a lot of what we do, it ends up being code along, especially when we're dealing with tutorials or online or learning new languages or data structures. We end up wanting to code along so we can do a lot of different things. Now, all 3 of these techniques, and there are more, but these 3 techniques, which should be simple habits to adjust, are based in the 6 levels of engagement. The more engaged you are, the more you're actually learning material. So we have no viewing, not showing up, paying attention to your phone, not paying attention to what's going on, looking things up, just answering a quick email. All those things tend to happen, which trigger your brain to no viewing. This is an important one, remember it. Viewing is watching. Maybe you're really trying to pay attention, but you're not really truly engaged. Responding is this asking questions idea, the idea that you want to interact with this content, interact with the presentation. But then we want to take it farther. We want to change, we want to construct, we want to build, and we want to present. And so when you're taking notes, you're starting to construct. When you're coding along, you're working with the material. And this whole thing says we start here, we work through here with our engagement. And once we have all that put together, then our brains actually start wanting to retain the information. So let's take a moment to talk about each of these techniques more in depth as habits that you can build to better learn computer science. So ask questions. It is critical for engagement because what you're telling your brain is, it's not so much that you don't understand it. What you're telling your brain is, this is important enough. I want you to reflect on it and try to understand it in a different way. And so now this information is being reinforced in your brain because you chose to ask that question. Yet few people actually ask questions. They are sort of afraid of it. And even more to the point, they say, if someone else asks, that's all right, I'll understand it better. And in truth, we really need to be the ones asking those questions to help reinforce it. Or engaging once a question's been asked and saying, oh, this is great, but can you clarify this a bit more, understand a bit more here? And in person, that is why in-person lectures feel often why you're learning more, because you have this opportunity to ask questions. You have this opportunity, more importantly, for the instructor to ask you a question, which then engages your brain to reflect upon it and say, can you recall this information? Online, you really don't have that. Even synchronous online, it's really difficult for an instructor to ask questions when they don't even see the person's faces. And they don't know how engaged they are with the course, because maybe they're off somewhere watching Netflix while watching the course or doing something else that's going on synchronous. And so you tend to lose a lot of that. So as an online learner in particular, you want to make use of the tools. You want to gather your questions. And maybe your tool is an MS Team where you talk and you discuss and you have this chat, or maybe it's a forum, or maybe it's something like Piazza. But as an online learner, you have to ask questions if you want your brain to trigger, this is important, I need to better understand it. And sometimes those questions are even beyond the content. An instructor may say, hey, you've got a really great point, but this is beyond the content. We'll go ahead and cover this separately so I don't confuse people. Online, you actually have an advantage. They can do that. They can cover it a lot better because they are not necessarily confusing this discussion next to it. Notes. A common mistake people make with notes is they use provided notes. I did this throughout nearly my undergrad education and even my master's education. I would say, hey, professor, can you give us a copy of the PowerPoint slides? And I would print them out, I'd put them in a notebook, and then I would write maybe 1 or 2 words in this notebook, or maybe I'd draw something on it, but my notes were horrible. But it didn't matter because they were provided. I could just look through the slides again later. Or someone else provides your notes. That actually takes out the benefit of notes. Notes are actually horrible study tools. You want to avoid looking through your notes again, other than maybe briefly browsing them, but they're not really meant for study tools. It's something called restudying. We'll cover this in a future video. The strength of notes is the creation of the notes. And it's not just words. You want to avoid definitions and say this is definition. You can pull that up. You can fill it in later. You can find the lecture slides and say, oh, here's the definition. But what you really want to do is draw pictures. And I don't mean stick figures, though. Sometimes my drawings are stick figures. What I really say is you're talking about computing. You're trying to understand the memory in the computer. So go ahead and draw a picture, what they're drawing on the board. Try to represent the lines. Try to understand how different functions are called. You're learning different things, so try to visualize it. And what this does is this triggers your brain to make an association. This visual representation of what the content you're learning with the lecture. So later when your brain goes to recall, it has multiple paths that it can get there. And it's proven time and time again that associations are critical and very powerful for our understanding of material. And sometimes that association is not necessarily what you think. Remembering names. You meet someone new. One of the best things you can do to remember their name, and admittedly I struggle with this because I always forget to do this, is you hear their name and you associate it with something. It could be, hey, you associate it with fruit. Or you associate it even better with someone you already know by that name. And you're like, hey, I know this name. I now know someone else by this name. I can make this association. And then you'll remember it better. They've tried this time and time again. It works. And when you are taking notes, try to create associations. Images are great ways to do it. Maybe it's scenarios or different words, or you can say, hey, here's this concept. I'm going to associate it here and better reflect it. You can also write questions in your notes. And then you have questions to ask later, depending on how the format is set up. But even more, you can fill in the gaps. You can ask a question and then fill in the gap. You can make an association and fill in the gap. So the key is your notes are not static. You can continue to go back to them and fill it in and use the creation of the content for better understanding. Let's talk about coding along. With computer science, this is powerful, and it's really participating along. It doesn't have to be for computer science, or computer science. This is the powerful tool to use. When you're watching a video, especially shines in asynchronous, it helps you create associations. It helps you create questions. It forces you to focus and engage. And admittedly, it's hard to do in asynchronous content. It's hard to do unless the professor provides some sample code beforehand. They usually have a bunch that they build and they dive right into it. The good instructor and synchronous content will help provide some of the code, whether it's on his slides so you can help set up your environment so you can follow along. But in asynchronous, you can pause it. You can say, oh, I need to go get this set up so I can do this. You can rewind, you can repeat. And the power of coding along is you are now getting your hands into it. You're creating an association. You're typing at this computer to help better understand this material. And it does wonders. And even more, you can explore it later. You've finished this tutorial, you've finished this asynchronous video, you've coded along with it, you've got it working. Now you can tweak a variable. Now you can tweak this. Now you can tweak that. Now you can sort of start exploring what you have because you have a concrete program in front of you, depending on what the code is. You have a concrete code in front of you that you can use. Coding along is one of the most powerful tools we can do in computer science. When you watch an asynchronous video, don't just watch it. Pull up your IDE, sit next to it, code with it, pause, ask questions, fill out your notes with questions, draw to better understand. And now this idea of watching where you're getting distracted, you may be answering text, you may be saying, hey, I'm going to take a look just one brief moment at Facebook, and you lose track of what's going on, is gone. Because you have to engage, because you're keeping up, you're interacting back and forth. You may have to pause it, go away for a bit, come back. That's cool when it's asynchronous. And I keep sort of references asynchronous, and the reason why is in computer science, that is a lot of our learning. Why is that a lot of our learning? We have to be constant learners. The field is too big to know everything. So YouTube, for example, is full of tutorials on basic topics. In computer science and technical topics, it is very rich, and there's forums talking about it. There are blogs set up for it. You have the Medium, which just focuses over and over on this computer science content, or Dev.to, which has all this. And so by tutorials, by furthering education, we as computer scientists can keep up with the industry. But to be successful, we have to interact with it. We have to give it a try. If we really want to understand it, other than just, we can skim it and say, oh, I've learned a little bit about this, but I don't care to know it. But if you really want to understand it, if you want to be good at it, you have to try it. You have to explore it. You have to get your hands dirty by coding. And by coding, I just don't mean coding is the only thing we do in computer science. I should say you have to get your hands dirty by doing it, because sometimes it is drawing a graph out. Sometimes it is figuring out the regular expressions, or it's figuring out the different trees, or maybe you're figuring out how you balance the binary search tree when you get there. There's all these different things that is sort of this hands-on approach that helps anyone. And research after research actually says it's going to help you no matter what you claim your learning style is. If you engage by coding along, taking these visual notes, if you ask questions later, you can be successful. And the biggest struggle people have, especially asynchronous online learning, is they sit and watch. They think they're going to learn by watching, and then they know something's not right, so they struggle. And they're trying to watch, and they know that they're struggling. But they're not sure why. And the why is you need to stop watching and start engaging. We need to stop watching and start engaging. That is how you can be successful in any course, no matter what the course is, no matter where the course is, especially when you're dealing with online. And the key is the choice is yours. A great student is in the power of the student. And that's something we forgot. We almost always give our power to the instructors, to the professors, to these people who are imparting knowledge to us. But the truth is you're learning, and a very powerful, empowering feeling is actually in your hands. You have the capability to learn. You have the capability to succeed. You have the capability to engage, and your brain will help you be successful. Thank you.